Yes, let's start. So before we start Pulley problem in Newtonian mechanics, Newton's laws of motion, by using that, let us do some experiment, numerical experiment, not very theoretical, with this kind of problem. It's a problem solving class on Newtonian mechanics. Okay, let us start with this sum. String of length L and mass M is lying on a horizontal table. Force F is applied at one end of its end. This is a string. In pulley also we use strings. Force F is applied at one end of its end. What is the tension in the string at a distance x from the end at which force is applied? So the problem in Newtonian mechanics, I have started with this, where cord has weight. Okay, cord is not weightless. Cord has some weight. It is thickness also, but we'll write as negligible thickness. This is the cord. Its length is L. At one end, you have applied a force F. What is the force acting at this point P, where P is at a distance x from the end where you have applied the force? Clear? Understand the problem? So it seems that someone is applying force over there. No. The pulley, the cord only, the part, if we consider cord is AB, this cord AP and PB we can divide in two parts. One can assume that when a force applied at one end, some force is applied at every point, that's why it is moving. According to Newtonian mechanics, if force is not there, starting of motion is not possible. So the cord will be in motion if every part exerts force on the immediate neighbor. So this part P, just if you consider this portion of the cord AP, this is applying force on this portion, that's why it is moving, we can assume. Force directly has no link with the point P. You have applied here, but a part of it will be effective everywhere, that's why the cord is moving. Got the point? So at this point P, how much force is acting? To solve this kind of problem, what we will do here, we will imagine that the cord is divided into two parts. One part is AP and the other part is PB. Okay? And between these two, there is a very thin string is attached. Okay? This string has a tension, that's why it is pulling. This mass is being pulled forward because this weightless cord, it has some tension, that you assume that T, that's why it is moving. Am I clear? So this force F gradually reducing from this end to this end. At this extreme end force is F, it is gradually reducing. You have to find what is the effective force at a distance x from the end A. So how to do it here? You imagine that in between these two, because pulley has some mass, so in between these two we can assume that there is a weightless string which is pulling the part BP in forward direction. But if it pulls the part BP in forward direction, the part AP, it is pulling in backward direction. Am I correct? So there is a tension at this point, means due to that tension, this part BP is being pulled forward, but this part AP is being pulled backward. Clear? So let us write the equations accordingly. So tension of this part you have assumed T, acceleration of it you assume that E. Okay, this part tension is T here, T is this way. So for this one, whatever mass it has and whatever mass it has, sum of these two masses is equal to total mass, isn't it? But how do I account for total mass? Total mass is given here. So you first find mass per unit length. Small m equal to mass per unit length. Mass per unit length is small m. So what is the mass of this portion? This portion has length x, this portion has length L minus x. Mass of this part is m into x. What is the mass of this part? M into L minus x. Agree or not? So force applied here is F. This is being pulled towards left by the tension T. So equation of motion of the part AP you write first. This is P, no? P is this point only, same point. So for AP, the equation of motion is F minus, this tension is opposing its motion, F minus T equal to M1 into A. Agree or not? For PB, how do you do? How do you write the equation of motion? What force is acting on PB? On PB, this T acting forward. That's why it is moving, no? So T must be equal to M2 into A. Have I done correctly? Check once. What I did there, at the point P, we imagine that there is a force. That force I have replaced by tension T of the weightless cord which connect. We imagine that it is divided there. So one end connected with the other due to this cord which is weightless. But given cord is not weightless. It has some weight. Normally cord's weight we don't consider. But here cord's weight is there. If cord's weight is not there, pulley problem will be of one type. If cord have some weight, then pulley problem will be of another type. Okay? So I have taken this one first to understand how when an object is moved at different parts, how tension acts. That's why it is moving. At this end you have applied a force 60 Newton. It doesn't mean that every point 60 Newton is acting. What force is acting at a distance x, that we are going to find. Okay? So how to get this? How to get that? Tell. We'll just divide. We'll just divide 1 by 2. Dividing 1 by 2. Better you do it with me. F minus T by T equal to M1 by M2. So this implies our aim is to find the value of T. You just separate. M1, M2 is what? Tell. M1 I have written here. Mass per unit length into x. What is the weight of M2? M into L minus x. So F by T minus 1 equal to x by L minus x. Clear? So this implies F by T equal to 1 plus x by L minus x, L by L minus x. Our aim is what? Our aim is to find the value of T in terms of F and L. X is also given. So T will be what? F into L minus x by L. F into 1 minus x by L. this is the tension at a distance x from the end on right side. When x is 0, what is tension? That is force only. X is 0 means right extreme point. What is the value of tension now? If I ask you at the extreme end, at the point B, what is the tension? Can you tell me? At the end A, tension is, for x equal to 0, T will be equal to F. What is its value at the end B? Does any force act over there? No. It is obvious from here also. Put x equal to L. L by L is 1. T is going to be equal to 0. Clear? Go for next one. Think about this sum. Figure shows the position time graph of a body of mass 0.04 kg. Read the sum carefully and start solving it before I start doing it. Position time graph of a body of mass m. M is 0.04 kg. Okay? Suggest a suitable physical context for this motion. What is the time between two consecutive impulses received by the body, and what is the magnitude of each impulse? I hope you remember what is impulse. What is impulse of a force? Effect of force. That is change of momentum. How do I account for that impulse of a force from the graph? From force time graph, how do I account for impulse? Try to remember it. Area under the graph. So now read the question once more. This is xt graph. From xt graph, what are the quantities you can get? Velocity. Is velocity uniform? It is uniform, obviously. If you consider the point from O to the point A, that velocity is positive. Here the velocity is negative. So what kind of motion is this? First tell me. In every 2 second direction is being changed. It was going this way, it was going towards right, and then moving towards left, isn't it? So now try to do it. Mass is given, change of velocity is known. Can't you write the impulse? Time I told you, you do either force into time or area or change of momentum. Do it now. Finish it. First find the velocity before impulse. What is the velocity? Tell. Velocity before reaching the point A. Impulse means change of momentum, no? So here one velocity, here another velocity. Here velocity is what? Before the point A, that is just before 2 second interval is over. Just here 2 second interval is over. U is equal to what? The initial velocity 2 by 2. That is 1 centimeter per second. Just after 2 seconds, this velocity is positive. I did not put negative sign there. This will be what? This is minus 1 centimeter per second. Now calculate change of momentum. Change of velocity you can find now. From there you calculate. This is centimeter per second. You must note it down. This one given in centimeter per second. So if you take this one as u1, this one as u2, what is pi? Initial momentum is what? 0.04 into 0.01 kg meter per second. This you can write Newton second also, isn't it? Momentum can, okay, you write kg meter per second, then it's okay. M into velocity. What about the final momentum? Pf 0.04 minus 0.01 kg meter per second. So del P equal to change of momentum Pf minus Pi. Just find its value. Tell how much we are getting. How much you are getting? Pf is what? Minus 4 into 10 to the power minus 4, and this is also minus 4 10 to the power minus 4 kgm per second, minus 8 10 to the power minus 4 kg meter per second. This you can write 0.8 into 10 to the power minus 3 kg meter per second. Is that clear? Understood? Now go for next problem. Just go through this one. Figure shows a man standing stationary with respect to a horizontal conveyor belt that is accelerating with 1 meter per second square. What is the net force on the man if the coefficient of static friction between the man's shoes and the belt is 0.02? Is the window open? Check once. No. Can you solve it? Done. Net force on the man will be what? Because man is moving with that acceleration only, no? So some external force is taking the man in forward direction. Man is not moving himself, but he is being moved. What is the acceleration of the man? Due to the conveyor belt, 1 meter per second square. So first part answer, net force on the man is equal to mass into acceleration. Because this is the thing, no? Friction is there between conveyor belt and man, but that we will not see. What is the net force? The acceleration he got, that multiplied by mass. What is the mass of the man? 65. 65 into 1 Newton. Clear? Now, what is the force of friction? They have asked this part also. Because from there only we can calculate acceleration. Force of friction, this is equal to mu mg. Remember the relation? Mu is what? How much is the value of mu? 0.02. Yeah, check. 0.2, sorry. 0.2. And then put mass, put acceleration. Mass is 65 kg given. this multiplied by G. What to take? If you have calculator right now, you take 9.8, otherwise 10. So this is what? 650, that is 130. Isn't it? So what is the maximum acceleration he can have? How? Because mass is 65 and the force of friction is this. So F max will be force of friction divided by 65. Meter per second square. Sorry, A max. Can you tell me how this situation arises? How is it possible? He is moving with conveyor belt. Okay. Suppose frictional force not acting on him. If frictional force is not acting, he cannot be stationary over there. Frictional force acting, and this frictional force has maximum value this much. Why? Because static friction is the maximum value of force of friction. So when force of friction also comes into effect, this man can take the help of force of friction. With that, how much acceleration he can get, that we are going to consider. The conveyor belt, when it is taking, his acceleration is whatever given there. What is the acceleration given? That is 1 meter per second square. But if we consider the force of friction, with the help of that, I am getting force of friction, maximum value force of friction from ground. I am a man of 65 kg weight. Then the frictional force acting on me is 130. Because of coefficient of friction, whatever given over there, it is 130. So if I push backward in forward direction, I will get that same amount of force. My acceleration depends on how much force I can get due to friction. Friction will move me forward if I push the ground backward direction. So what maximum force he can get, which is mu mg. So acceleration will be mu mg divided by m. I mean it is maximum, because static friction is the maximum force. You may not need this much, but maximum value of friction you can get from the ground is that. Based on, go for next one. Because pulley is our target, we have started with this kind of sums. We will solve many problems so that pulley thing is clear for you. You will also get some time to solve it. Think about next one. Truck of mass 1000 kg is pulling a trailer of mass 2. You solve it with me, check the answer with me. That will be good. No? I think you all can read the problem properly, no? It's quite obvious. Retarding force 500 Newton, that the trailer is 1000 Newton, truck engine exert a force of 6000 Newton. Calculate acceleration of the truck and the trailer and the tension in the connecting rope. This is a simple problem. Now, why I have started with cord with weight? Cord with weight is a problem. Cord with negligible weight is not a problem, because here cord's weight not given, truck's weight given, trailer weight given, and someone pulling it with 6000 Newton. So I will not be considering the mass of the cord here. Only because of this force it is moving forward. So how to get the acceleration of truck and trailer? They have the same acceleration. They have the same acceleration. Another thing I would like to say, in pulley problem, the cord will not be elongated. Even if you are pulling with the highest force, the maximum value of force, it will never be elongated. This is one of the most important conditions. And these cords have no weight if they have not mentioned. If they mention, the weight of the cord that you have to take into consideration. So you take acceleration of the system as A. This connecting cord, like the first sum, what is the role of this connecting cord? It will pull 1000 kg back and it will take 2000 kg in forward direction. So if I take this one 2000 kg, it is being pulled towards right and acceleration is A. Okay, and for 1000 Newton, what is happening? 1000 kg, this 6000 Newton acting forward, tension acting backward, acceleration is A. Write the equations of motion for two separately. I have drawn the diagram which is known as free body diagram, isn't it? This is called free body diagram. So write the equations of motion. 6000 for this one, for this body. This is A and this one is B. For A we are writing 6000 minus T equal to 1000 A. Am I correct? Mass into acceleration. This is number 1. And for this one, T is equal to 2000 A. You did not ask me anything about gravity. Does gravity play any role over there? No. Because gravity acting vertically downward, it has no role to play the object in forward direction. So this mg has no role. This mg also has no role. Only horizontal force. Now just add these two. 6000 will be what? 3000 A. So A will be 2 meter per second square. Isn't it? So acceleration you got. Tension in the connecting wire is how much? T will be how much? Tell. T will be what? You put A over there. 2000 into 2. That is 4000 Newton. Understand? So whenever you are answering descriptive paper, you need to draw the free body diagram this manner and write the equations of motion. Question is with you. Check once. Oh, retarding force 500 is there. That I did not consider. So I have to consider it here. 500 minus 500. Retarding force I did not see that part. And you will be considering here also. Isn't it? Check. Write the equations of motion again. If we ignore friction, then those are the equations of motion. But friction is there, you need to write. Do complete the sum. Oh, that is 500, but this is 1000 given, no? Trailer. On the trailer it is 1000. So this will be 6000 minus 1500. No. Why 13 by 6? So correct the sum, it will be 4500 3000 A. This is what? 15 3 by 2. 1.5 meter per second square. So writing with friction is better. Otherwise only without friction it was nothing. But I have done both. No. If no friction is there, confidently you will write the previous equations. If friction is taken into consideration, just friction property, you know, it opposes the motion. So acceleration known. How to get tension over there? Tell. Tension will be, just put the value of A over there. Check how much. Put the value of A. 1000 plus 2000, 1.5, 4000. 4000 Newton. Clear? Understood? So you can now do by both the method. If friction given, okay. If friction not given, then also okay. Be confident. Clear? Go for next one. Read next one. Oh, just a minute. Length is increased. I have to use the length. Just a minute. Screen size is increased actually. Read the question. Horizontal force of, I hope you can do it now. Before I do it, you finish it. 500 Newton pulls two masses 10 kg and 20 kg connected by light string. What is the tension in the string? Does the answer depend on which the mass is pulled? You have to find tension. Think. Yeah. See, situation is very clear. Here it is on 20 kg, 10 kg, and here it is on 10 kg, 20 kg. Understood? Acceleration will not change, but tension, you do find it. Find it fast before I do it here. Yeah. You compare tensions. They asked you to find the tensions only, no? You compare by finding tensions only. So for this one, tension will be acting forward for 10 kg mass. For 20 kg, it will oppose. So write the equation of motion here. 20 minus t equal to, suppose in this case acceleration be a1 and here acceleration be a2. Okay? So write the equation of motion. What is that? Tell. How to write equation of motion here? For this one, 500 minus t equal to 28. No friction is there. And for this one, t is acting. Am I clear? Do I need to write the free body diagram separately here, or you have understood? For different mass, if you draw different diagram, then you got a free body diagram, no? So write the equations here. That is T1, the tension you have considered. Here let it be T2. Okay? So let us find the value of acceleration first. So 500 equal to 30A. 1. A1 is 50 by 3. 5,000. 500 given. And for this one, how will you write? 500 minus T2 equal to 10A2, and T2 must be 20A2. 500 equal to 30A2, tension will be the same, because only external force here 500 Newton, here also 500 Newton. So tension, acceleration will remain the same, but tension, you just check what is the value it's coming here. Here tension is what? 10 into 50 by 3, isn't it? So it is 500 by 3. What about this case? 20A2. This is okay. So it depends on which mass you have exerted the force. Think about next one. Hurry up. Finish it fast. Number 6 here. Compute the acceleration of the block and trolley system as shown in figure. Coefficient of kinetic friction given. Intentionally I have given mu also because you all have finished Newtonian mechanics. Friction is an integral part of it. So you can write the equation of motion for 4 kg, then for 30 kg, and then solve it. You recognize this? This one is my table end here. Here at the end of table, you have fixed up a pulley. Mass is on the table and one is hanging mass. Clear? Write the equations of motion. Just tell me one thing before you start. In what direction you think the system will move? Along the direction of 30 kg, no? It is greater force. So system will go down or 30 kg will pull it towards left? Can 30 kg take the system leftward? Never. Because on 30 kg gravity is the only force. How much gravity will act? How much gravity is acting over there? Tell. 30 g. It has no role this way. This 4 kg, on 4 kg, what force acting? That force is in vertical direction only. That is 4g. Isn't it? Let tension of the cord be T. Tension be T. Okay? So gravity is not responsible for the motion for 30 kg mass, but gravity is responsible for the motion of 4 kg as well as the whole system. This is the only external force. External force 30g is acting, but it has no ability to move the system in horizontal direction. Clear? So now write the equations of motion. So tension is T. If you draw the free body diagram on 30 kg, what are the forces acting that you need to draw? 30 kg, 2 wheels also there, and tension is T. So here force of friction is acting and T forward. You first assume that acceleration of the system be A, this manner. Okay? This is also A. So this is force of friction F FR. How much is this? Mu mg. That is 0.04 into m is 30 into 10. 300 0.04 12 Newton. So write the equation of motion here. T is acting in forward direction and F FR backward direction. Acceleration is A. Should I take 30 kg into consideration? No. 30 kg has no role to play. Frictional force contribute. Oppose, that's why. T minus 12, 38. This is number 1. What about this thing? This 4 kg mass. On 4 kg, tension acting upward, 4g downward, acceleration A downward. Isn't it? Can you tell me why? Because most of you have some idea of rotational mechanics also. Can you tell me how tension on two sides should be the same? We always assume that tension here equal to tension here. Why? Who told you that they will be same? May not be. Why did you consider? Can you prove it? By using the concept of rotational mechanics, it can be done. Here pulley is fixed, pulley doesn't rotate. To rotate the pulley, you need different torque on it. Okay? If tension different, this tension be T2 and this one be T1. Then pulley can rotate because unequal torque will be there. There will be rotation of the pulley. But here pulley will not rotate. It is fixed. That's why tension T1, T2 cannot be different. It is same. So write equation of motion here for this. 4g minus t equal to 4a. Clear? Now solve 1 and 2. Adding 1 and 2. Just add 1 and 2. 4g minus 12, 34. My God. What can I do? It is 12, no? Make mg. This is 40. 38 equal to 34a. So 19 by 17 meter per second square. Then find T by putting this. Tension will be what? 30 into 19 by 17 plus 12 Newton. Simplification is yours. I am not going to do it now. Understand the concept? Good. Do next one. Next one I want to see all of you are solving it before I complete it here. Start. This one. 3 blocks are connected as shown on a horizontal frictionless table. Pull to the right with the force of T3 equal to 60 Newton. Okay? These 3 masses are given. Prove that T1 by T2 equal to 1 by 3. I have not given traditional sums to solve. These are uncommon. If you can solve these, any problems can be started. And this is the introductory class on Pulley problems. I have so many methods to share with you for complicated pulleys. I cannot wait for that, but you know this thing first. 3 blocks are connected as shown on a horizontal frictionless table and pulled to the right with the force of T3 60 Newton. Mass is given, find T1 by T2. You do it by free body diagram if you are comfortable with that. Do it by free body diagram. It helps, no? Free body diagram. So, draw it for M1, M2, M3. Even tensions I have given there. T1, T2, T3. You do yourselves, then check my calculation. These are called free body diagrams, what I have drawn here. Okay? So, okay, right. I will not tell you. Do it first. Now check with my calculation. I have written all 3 equations. You understand? Now for this kind of problem, normally all get cancelled, all tensions. Yes, if you add, only T3 will be there. T3 is given now. You just add. Adding T3 equal to M1, M2, M3 into A. Clear? So if you put the value of T3 there, 60, and this is 10, 20, 30, A. So A will be 1 meter per second square. So T1 will be what? 1 into, M1 is 10 into 1. So T1 is 10 Newton, T2 is M2A, M2's value 20 plus T1, that is 10 Newton. And the value of T3 is M3A plus T2. M3A is what? That is 30 into 1 plus 30.
Sir, then the T3 is 60 only.
Let me check how it can be. It is not possible. T3 equal to M3A plus T2. T3 is 60 only, sorry.
So, sir,
60 is coming by calculation also. I forgot to put the value over there. Okay, it is 60, no problem. T3 is 60. So I got T1 and T2. They asked you to find T1 by T2. What is T1 by T2?
1 by 3.
Clear? Go for next one. Truck tows a trailer of mass 1200 kg at a speed of 10 meter per second. I'll explain everything. Weight on a level road. Tension in the coupling is 1000 Newton. What is the power extended on the trailer? Or find the tension in the coupling when truck ascends a road having an inclination of 1 in 6. It means tan theta is 1 by 6. I mean this part 1, so this part will be 6. It's like that. Clear? 1 in 6 means that. Assume the frictional resistance and on the inclined plane this is number 8. Read the sum and start. Power formula you need to remember, but Pulley related here. Power equal to force into velocity. All of you know it. Don't worry. Proceed. So this is not very common sum given in the books. This language is also not clear to you, I think. Coupling they have given means truck and trailer. Coupling is the force of this cord. Okay? This they have given. Coupling is 1000 Newton. Okay? Then power how to find? Force into velocity, isn't it? Or force into distance that divided by time. Ordinary definition. So for truck, what force is acting? Have they given the force here? Weight is given over there. Truck tows a trailer of mass 1200 kg. Trailer is this. Its mass is given. Truck's mass not given. Isn't it? So regarding truck, they did not ask anything. On trailer only.
Sir, then power should
Truck is pulling the trailer by what force?
1000 Newton.
No. No.
Which
Power extended on the trailer.
mg cos
mg sin theta. Down the incline, the force act mg sin theta. Because if its weight is mg, then if you divide into component, this way it will be mg. Component down the incline is mg sin theta perpendicular to the incline is mg cos theta, and this part is mg. Let me write. This is mg cos, this is mg sin. Here coupling force is 1000 Newton. So net force required will be what? That is 1000 plus mg sin theta. Okay. Tension in the coupling. Tension in the coupling
The coupling is mass instead.
yes. This is how much? That is 1000 plus mg sin theta. But there is a problem. Here they have given tan theta. Putting sin theta will be difficult. I tell you one clue here. Tan theta 1 by 6, it's a small angle. So you can write sin theta is approximately equal to tan theta equal to 1 by 6. Put it there. 1000 plus m is how much? 1200 into 10 into 1 by 6. So this is going to be 3000. Please check. It's okay. This is done. So tension in the coupling will be how much? 3000 Newton. Clear? Go for next one.
The
Power.
30,000 watt.
Just put it there. Power equal to F into S by T. They have given distance. Tension in the coupling given.
They have given speed.
They have given, so multiply it by speed. F into V. F you got, multiply that by V. Do finish it. Power equal to F into V. Just multiply and tell. Now go by the next problem. In the given arrangement, if the points P and Q move down with a velocity u, find the velocity of m. How will you solve the problem? Yes. This problem given in H. Verma also. This velocity is u given. Velocity of m depend on what? This velocity will be upward this way, no? It will upward. This one pulling, this one also pulling it. So there is a contribution of this one, there is a contribution of this one also. If this one pulled with you, what is the velocity of this? We have to find. I am just showing you one vector triangle here, this one. Okay, this is close to the point of suspension, no? So you take this one as x, this one as y. Length of the chord is L. So if we apply, why I am considering this thing? Because here velocity of L is given. What is velocity of L? This velocity u only. We need to know velocity of what? That is y. Tell me one thing, here x is a constant or not? Just think. Solving problem is not the actual problem. Thinking is required. X is this distance. This one. So this portion going to be 2x. Is it changing or fixed? This you need to answer. Pulley system is there, two pulleys. In between that portion, if it is bounded over there, pulley is not moving here, fixed. So this length 2x is fixed. So the length x is also fixed, isn't it? This part is y, this part x, length of the cord is L. This length of the cord is L. So we can easily apply Pythagoras theorem over there. X square plus y square equal to L square. Clear? This is known. You will say that no, it is not very close. This pulley is not close to the point of suspension, and pulley center same at the same place. Okay? And x is not constant due to movement of the mass or pulley string. This 2x is not going to change. It is fixed. So x is a constant. Which one changing over there? X changing thing is y and L. What we are going to find? To find dy by dt. Under what condition? When dl by dt given. How much is this? dl by dt, that is u. Agree or not? Think this one. Why am I considering dl by dt equal to u? Tell me. Why am I considering dl by dt is u? Because this cord, this one and this one, this cord is passing over the pulley, no? This cord is passing over the pulley. Length of pulley is same. And pulley is not, cord is not extensible. So whatever velocity you give this end, with the same velocity, this end will move. Am I clear? If I have attached the same cord, then if this one has velocity u, by pulling, this one should have the same velocity u. Now this relation you differentiate. This relation. What will you get? 0 plus to L dl by dt. What do you want? What do you want? dy by dt. So dy by dt equal to L by y dl by dt. What is L by y in the diagram? In figure, y by L is what? Cos theta. So L by y is 1 by cos theta. So 1 by cos theta, and dl by dt is what? dl by dt is u. See this one? Put it there. So value is going to be u by cos theta. Am I correct? Understand? So these are simple pulley problem. But another thing I'd like to note it here. Just this kind of pulley problem, how do you solve? Pulley is on inclined plane. Just let me draw the diagram. This is a pulley and this is the cord. Okay, here also the same manner, same cord, only passing this way. Okay, this one has mass m1, this mass is m2. This angle theta 1, this is an wedge. Wedge has two ends inclined this manner. Okay, this is fixed, this is not moving. Okay, this wedge is resting on the ground. On its top, a pulley is attached. Two masses are attached with it. Your problem is to find tension and acceleration. Tension of the cord, same cord there, no? Acceleration of the system. Find acceleration of the system and the tension of the cord. Do it before I solve it here. Theta 1, theta 2, m1, m2 will be given in the problem. But you just solve with these quantities. Find acceleration of the system and tension of the cord. Tension you will take same on two sides of pulley. Then what to do? Free body diagram. Free body diagram, you draw isolating M2 and M1 from there, or you don't isolate, keep it there and do. So here for M2, M2G acting downward, component down the incline, M2G sin theta 2, and this way M2G cos theta 2. Clear? Done? Similarly for M1, what are the forces acting? M1G downward. This way it will be M1G sin theta 1 okay. If friction is given, one situation, friction not given, there will be another situation. Initially I am solving it without friction, no friction is there, it is smooth. So your calculation also very smooth. You write equation of motion for M1, but there is a problem. System goes this way or this way. We can consider. We can assume that it is moving this way or going this way. Any direction, your choice. Now suppose acceleration of the system be A. So this is also A. Assuming FR equal to 0. So equation of motion, I have drawn the free body diagram in the same diagram, no problem. T minus M2G sin theta 2 equal to M2A. Am I right? Along the incline it's moving up. So mass into acceleration. What about this mass? This mass is being pulled down by what force? M1G sin theta 1. So M1G sin theta 1, M1G into A. You agree? I have written both the equations correctly, isn't it? Now, how the situation going to be changed when friction is there? Told you no, if friction not there, then it's fine. But if friction is there, then what to do?
Second equation M1 A.
M1?
A.
Okay, I'll check. We'll check. Sorry, G by mistake it has come. It is M1 into A. Now, if friction is there, then what will happen? Friction is present. So, I have to modify the free body diagram. Here only, I will be taking the frictional force into consideration. What way? Same way. Let us assume that acceleration of the system be A. When this one going up, what will be the direction of force of friction? It will be in opposite direction. When this one going down, what will be the direction of friction? It will be in opposite direction, because friction always opposes the motion. Fr1 and this one Fr2. I mean frictional force 1 and here frictional force 2. Now can you try to write the equations of motion? What is the force of friction when a body is on inclined plane? If the coefficient of friction is mu, mg down, mg sine, this way mg cos, isn't it? Mg sine, mg cos. Force of friction, how do you find? Normally action will act this way, force of friction will be opposite. If it has tendency to go down, and what is the value of frictional force? Same formula here, mu into n. What is mu? Coefficient of friction. N equal to what? Mg cos theta. Clear? So when you are going to write the equation of motion here, that frictional force, what frictional force acting? Mu into what? M2G cos theta. And what frictional force acting here? It is up the incline, Fr1 del mu into M1G cos theta. Write the equation of motion. For M1 mass, how do you write equation of motion? M1G sin theta 1 minus T minus mu. And for this one what? T minus M2G sin theta mu M2G cos theta equal to M2A. Clear? Understood? So this is just starting of Pulley problem. Many problems are there on Pulley which you need to solve. I just show you two more examples to do. Very first, on this table only, this is the table, two ends, two pulleys are attached. Here one pulley, the other one is here. Two pulleys are there and there is a mass in between. Sorry. There is a mass in between. Mass suspended here also. This is M1. This is M2. And this mass is M3. Okay. Now question you see that find the acceleration of the system and the tension.
Sir, and the acceleration only in
That is up to you. When listen, you can take any direction, but actual calculation, if acceleration gives negative, then system is not going that way, it is going opposite direction. So I'll tell you to solve this problem again by considering when friction absent, when friction present. Okay? Friction coefficient be mu. When friction present.
sir, tension will be different, right?
Yeah, of course it will be different. Case 1, when FR equal to 0. I mean no friction is there. Which mass is larger, that we don't know. Even larger mass will not ensure that it will go that way only for inclined plane. So okay, let us assume that system going this way. Acceleration A, okay, Fr equal to 0. So write the equations of motion. This tension be T2, T2, T1, T1. Clear? Done? So system moves leftward, no? Leftward. So write the equations of motion. When Fr, force of friction equal to 0. M3G minus T2 equal to M3 into A. Number 1. For this central mass, what you will do? Here for M3, it was like this. T2 upward, so equation of motion. For M2, what will happen? If you go by free body diagram, it is being pulled towards left. It is being pulled towards right also, but resultant thing is acceleration here. So this one's free body diagram shown, you all can write the equations of motion. That is T2 minus T1 equal to mg, isn't it? It is not mg, it will be m2 into A. Clear? Mass into acceleration, because it has acceleration A only towards left. For M3, what to do? Draw the free, you can see the free body diagram. M3, T2 up.
Sir, M3 have already made.
Oh, M3 we have written. So we have to do it for M1. M1 is falling.
M1 is equal to T1 minus
M1 G minus, this is the style of writing, no? All those external things you write.
T
Minus T1, wrong. Oh, no, that is right. You are right. Because this mass is going up. So T1 minus M1G. Am I correct? Done? You can find tension, you can find acceleration. If friction is there, how do you modify those equations? If there is friction, this one and this one will remain the same. You agree or not? Only this thing will be changed. T2 minus mu M2G minus T1 M2 into A. When friction is there. Am I correct? So basic idea of Pulley problem done. Next session I will be discussing complicated Pulley problem once by coefficient method, That is not new. People are using that method also. And number two is what? Length of chord constant. These are very simple problem we have done. These are important for school based examination. But if you don't learn this, you cannot go for any other examinations. You have to learn it properly. So the most important question for you was that prove that T1 equal to T2. I hope you will remember.